Hello, I'm Ivana Tanasova from the Network Service Mesh community. And in this talk, I'm going to share with you our community efforts for visualizing the network topology with NSM and also the traffic that is going between the different endpoints. And to start with, let's say how the traffic is represented in a point-to-point connection that is created by network service mesh. Once the client and an endpoint start to talk with each other, they receive and transmit bytes packets, and which we represent by RX and TX bytes and packets. And we also have RX and TX error packets, which are actually the dropped packages in that communication. And this is so good, but you may ask how you can actually observe those and how you can see what's going on with your connection, what fails to be received. What we have by now, we did an integration with Prometheus, which presents metrics for all those transmits and received data. In the diagrams that I show you, I used 4G LTE network example. It's located in the examples repo. The example generates some traffic between the different clients and endpoints in it. And this is the traffic that you actually see. In Prometheus, we have vectors for RX and TX bytes, packets, and error packets. And in order to observe specific connection, you need to check a vector, for example, the TX bytes. In this example, you see the transmit bytes between the packet gateway and the PCRF. In this example, you see the TX bytes between MME and HSS. I also add an examples for the RX bytes between those. And as our 4G network example doesn't generate any error packets, this is why this diagram is empty. But if in your use case you have some drop packages or other problems, you will be able to observe them with the error packets vectors in Prometheus. Yeah, this is a good way to visualize traffic that we have by now, but we want to have something even better than that. Some good and interactive way to see the whole network topology and what's going on with the connections. We found a project in GitHub that looked really cool. And we very much wanted to have that visualization for NSM and to see in such a good way all the network that we create and to see all the packets, to can check them specifically, to have statistics. And we tried to integrate with that project, but this way what we actually, where we actually reached. It doesn't look as in the example. And the reason for that is first that the project was abandoned since 2 years, which we actually missed to check in the beginning. It has some issues that weren't resolved since those 2 years, which were blocking for us. And in the beginning, we started to try to resolve them on our own. We thought that it will be simple, but new issues appeared when trying to get the project up to date. It came out that it's really hard to estimate how much time and effort this will take. And the more serious problem is that if we fork that library and fix everything. We will need to support it in future and to have one more project to support just to go on with NSM in order to have that visualization, to always update all the versions. And it didn't look very efficient for us, even though it looked pretty nice. And we very much want to have such good visualization. But this is what inspired us to think in that direction and to search for something else. Someone presented about Kiali in our community meetings, and we liked this as an option. It is created for service meshes, and this is one of the reasons we also like it, because it's widely used in Istio. It has several benefits: that it's interactive, it has good topology representations, you can observe traffic, there are some validation options within the project, it provides metrics, but it also, when we investigated the project and what we can do in order to integrate with it, we had some problems. The first is that it is very tightly connected to, it is created for Istio, and it's not abstracted, so that you can easily use it for another service mesh. Everything within the project was specifically created for Istio. We found out that there is a team within AWS which integrated Kiali with Linkerd. I contacted the person who did that integration, but he didn't work for that team anymore. And then I contacted the team and tried to make some collaboration. I couldn't actually reach out, so that it came that if we choose that, it will be our own effort, and we cannot exchange experience with other teams. At least we didn't know about any other team at that point. We estimated that it would take a lot of time to do that, and we need an agreement from the community, or we need to do that on our own on some fork, which is actually not a good approach in open source. So in order to use Kiali, we need a good proof of concept. What we mean by that, we need to see that there is a community strategy within Kiali to decouple from Istio, which wasn't visible at that point. And we wanted to make sure that this is a project that will be alive and supported for a long time, that it has a wide adoption, or if it doesn't have at the moment, that it's working in that direction, and it has some signs to be used from other service meshes. And I shared those ideas with the community and get some feedback about the Grafana plugins, the diagram and flowchart plugin. They are two plugins that are actually good for our use case. We did a representation with them, and it looked really nice in terms of the topology. It shows the vectors, the traffic that is going on, but it also has some problems. The biggest problem is that all that diagrams that you saw, the graphs that you saw, they were created by hand. They actually need a predefined topology that you write for those plugins, and then you run Prometheus, and then you get the data. And this is not very efficient because you need to do that for every different use case. Here, there is a good solution. If we implement a network topology CRDs that describe the topology, uh, we can use them, and we can easily integrate. We can write an automation that converts those CRDs to a format that is readable from the Grafana plugins, and we can we can automate the process and have the diagrams. But this is something that is maybe a good solution to look at in future. Not yet available, but is still an option. I also received feedback from Matthew Rohan from our community. He shared about this Hubble project. And it looks really nice, lightweight. It's easy to run. It is exactly what we need because it represents topology, and it shows the connection, and it shows the traffic that is going on between them. It shows all the failures and all the information that we need. We run that for it also has good charts that are that can be used to observe the traffic, and we try to run it with our 4G LTE network example to see how if it works for NSM without any additional efforts. It creates the network easily, but it failed to recognize the connection. Then we reached the Hubble community. We created an issue, and they pointed out how we can easily resolve that problem. So in order to have a representation with Hubble, we can have a pretty simple fix with NSM so that the connections will be recognized by Hubble. The project looks good. It has everything that we need. So it seems healthy. What I mean by healthy, it's active. They respond pretty fast to issues. It looks well implemented, and there are not actually any concerns about using Hubble. This is one of the best options, in my opinion, to integrate with. What else we have? We have Skydive. This is a project that we already use. It represents it visualizes the Kubernetes cluster and all the pods that are created in our network. And it already supports traffic metrics. But what is the problem with them? It represents the metrics that are represented with Skydive are between specific network interfaces, and the network interface is not something very human readable, and not a good way for a person to to check a traffic between specific endpoints, because you need to find out what the network interface is, and it's much better to have that matrix data between specific pods. So for that, we opened an issue in Skydive to form a discussion with their community and share what we want to have. And we have several options. One is to add our metrics that we have different from the metrics of the network interface is our vector representation. we can add them to the Skydive UI, or we can implement a separate Prometheus probe that takes all the data directly from Prometheus, represents the network topology, and show all the data. The good thing is that Skydive is already integrated with network service mesh, so that if we use that, we will have the same solution, but we'll have some additional data with it. So it's pretty nice to have that. So what's next? What we need to do in that direction? For the visualization, we need to choose a project from the listed solutions, or maybe if some new and really great solution comes, and we need to write an integration about it. We also need to update our metrics to support the path concept and to get up to date with the cross-connect, the new cross-connect API. And one of the goals of this presentation is to check with the community and anyone interested with NSM what you'd actually like to see, how what you need in terms of visualization, what are your preferences and needs, and anyone that is also willing to get involved in that effort, you're welcome. We are open for questions, for any shares, ideas, feedback on this. And yeah, we want to thank to the sponsors of the event. And with that, I'm going to say thank you, and I'm happy to hear your questions.